Page number 49.
14.
Part 2, Occluded Front Simulation. Introduction. Middle latitude cyclones, or storm centers, are regions of low pressure that generally travel from west to east across the United States. These systems last from a few days to more than a week and often cause abundant precipitation. Most middle latitude cyclones also have a cold front extending from the central low pressure area with a warm front frequently ahead of the cold front. In this activity, we will simulate the interaction of three conflicting air masses which are commonly associated with mid-latitude cyclones. In your diagram here, I'm going to set this up where the center is warm water. This side will be cold water. This side over here will be hot water. Red hot, clear warm, blue cold. Go ahead and color in your drawing as I get it set up. When you finish with the coloring, make the hypothesis. Predict how the fluids will interact once the partitions are removed. Defend your answer. So I will remove partitions from these two locations once we begin this experiment. Okay. Mr. Denman, could I borrow you for a minute?
Wait a second.
Put this inside of the thing. At the same time, I just Yep, we're gonna do it at the same time here. Ready?
Yo, every year, like our plans on what to do. What? Every year, for all of it, I don't know what to do. Let's see, we're not doing Easter egg hunt like we were to outside. So, because my grandma, she can't go outside. Well, she's still in the
Oh, yes, grandma, my grandma.
Is your grandma home? Yeah, she's at home. She's like on the couch. So, my baby James is like, oh, well, I mean,
No, you gotta spell it.
oh, well, I know they have an Easter egg hunt where they
Don't worry about that yet.
Pretty serious.
Take that.
When did you ever see anybody iron?
Thank you, sir.
Your mom.
Yeah, I can see that.
And then she was like, oh, me and Drew.
You should have your hypothesis.
And then, my aunt was like, me and Drew did it, and mom was like,
Hey guys, we need a little less than that. Once you are done writing out your hypothesis, you need to go down below and color in what you believe will happen based on what you wrote for your hypothesis number 2.
That's what's gonna happen.
Alright, so what I'm going to do, I'm going to take the partition and I'm going to put the partition in here. I'm going to put the other partition over here on this side. Like so. Okay, I'll take the ice out of here. And I'm going to remove the middle partition so that I have water that is halfway between the temperature of these two sides. Okay, does that make sense?
Yeah.
So now this water I'm going to mix all up so that it's a different temperature. All three sections will have a different temperature. And I'll read off the temperatures here in a minute.
All the way from
It's like got like heated up somehow, and then like it was
And it would change the temperature. Oh, would it mix? It might not mix.
The red's starting to leak.
the red's leaking.
That's all right. It's okay. I'll hold it tight. All right. Temperature over here of the cold water is about 32 degrees Fahrenheit, 0 degrees Celsius. The center one is at about 20 degrees Celsius, 68 degrees Fahrenheit. The warm one over here, 100 degrees Fahrenheit, 38 degrees Celsius. So we go cold, warm, hot. Everyone has their hot plate? Yep, make sure you got the drawing for what you think will happen. So visual representation, what do you think will happen, and a written description of what you think will happen. Okay? I'm going to conduct the experiment. For the observation, you are going to write down what you observe. Okay? Here we go.
Looks like a duck. See the duck. Oh, that's sweet. Oh man. Yeah. The boozer was like slow. So warm water. Yeah, it was faster.
No, it's kind of cold now.
Water because it's
See, the water is more solid than the hot water.
My picture was right.
I gotta let them know. It'll flood.
I drew mine. It was
I
like
probably did.
Pepsi sign. Pepsi like that. The world revolves around Pepsi.
Literally.
That's why.
Please, under the observation number 2, describe what happened. Was your hypothesis correct or incorrect? And then question number 1, what type of front would this simulation have represented when the cold and cool masses made contact, lifting the warmer mass? What type of front would this represent? Go ahead and write it down. Let's look at the extension questions. Number 1, why do fronts almost always bring precipitation? What occurs at these frontal boundaries to almost always bring precipitation?
The warm behind it brings the when water comes in, it's bringing in I don't know.
Okay. No, it doesn't have to do with the pressure change. Well,
So like
not. We're looking for something that happens in the water cycle. Caden, what were you thinking?
oh, looking at that, when the cold, the heat, the warm, the cold has like
Yes, cold is denser. That is true. That's why it's on the bottom.
upper.
And the heated water is less dense, therefore it's floating on the top. But that doesn't explain why we end up with this situation up here.
I still got that.
Cloud formation along these boundaries. Got cloud formation occurring along these frontal boundaries. Why do we end up with cloud formation and eventually precipitation? Due to these frontal boundaries. Yes, ma'am. Yes. Why does condensation occur? What is causing condensation to occur at these boundary locations?
Yeah, this is what
Yes, ma'am?
Cold air is cooling down the hot air.
Okay, cold air is cooling down the hot air. And the hot air probably had a lot of evaporation occurring. There's probably a lot of moisture content in that warm air. As we cool that warm air that has a lot of water vapor in it, as it cools down, condensation can occur. Number 2, why do middle latitude cyclones, or low pressure regions, move across the United States from west to east? You gotta think back to the notes that we did. Think back to a lesson we did about a week ago. It might have been about 2 weeks ago. What would the reason be for the low pressure systems that come across the United States? Why would they go from the west to the east? Mr. Clayton?
How would they go from west to east?
Yes, sir.
Because I want to say it's kind of like because of that tilt that
Okay. The tilt does cause uneven heating of our planet. The uneven heating of our planet leads to what? Our planet is not heated evenly. Because our planet is not heated evenly, we have not fronts, kind of. We end up with warm air masses meeting cold air masses, but something else. I'm thinking something that happens on our planet and it happens consistently at different locations along our planet.
uneven pressure.
Uneven pressure, so uneven heating leads to uneven pressure. That uneven pressure leads to what?
Global winds.
Global winds, very good. Uneven heating leads to uneven pressures, which leads to global winds. So the question is, why in the United States do we have systems that move from the west to the east? Okay, what are the global winds called that move across the United States? Yes, sir? The westerlies. The westerlies are the winds that move from the west to the east in the northern hemisphere between 30 degrees and 60 degrees north. They also occur in the southern hemisphere between 30 degrees and 60 degrees south. So the westerlies blow all of these low pressure systems from west to east. Number 3, why do middle latitude low pressure regions, or middle latitude cyclones, why do they take on a spiral or a comma shape? Why do they take on a spiral or comma shape? Yes, ma'am.
It's normally like the extension questions were into them. Okay, so it's like because the pressure is the pressure coming out.
Okay. A mid-latitude cyclone is what type of pressure system? Low pressure system. Mid-latitude cyclone is a low pressure system. What do we know about wind rotation in a low pressure system? Not necessarily. In the middle latitudes, yes. If it was in the westerlies, it would move from west to east. That's true. But what do we know about a low pressure system and how its winds move? Think back to that short section of the Simpsons episode that we watched. Mr. Weeks? The question was, why or what do we know about a low pressure system and the way in which the winds move in a low pressure system? And then I said, think about the Simpsons episode, the short little section of the Simpsons episode that we watched.
Yeah, Morgan, let's hold him and Smith. Oh, okay.
You got it, Mr. Weeks? It is different between the northern hemisphere and the southern hemisphere, but what is it? Yes, ma'am.
It's like when the water moves, like the other counterclockwise,
In what hemisphere?
the northern.
Northern hemisphere, a low pressure system rotates counterclockwise. Okay? Low pressure system rotates counterclockwise. So the winds blow in counterclockwise towards that central region of low pressure. What does that do to? Why do we have that occur? Why do we have that occur? Mr. Grant, what do you think? The spin of what? The Earth. The spin of the Earth is true. What do we call that? It's got a name. Not rotation. We're talking about the effect. The effect. Coriolis effect. The Coriolis effect causes this counterclockwise rotation of low pressure systems in the northern hemisphere because our atmosphere is deflected due to Earth as it spins. Okay? Next one. Why do clouds form and why are they abundant near frontal zones? So up here, why are clouds forming and why are they abundant near frontal zones? Much like the question that we already answered. Ms. Shaylin, why do clouds form near frontal zones? Clouds form during frontal zones. So up here on the board, we've got frontal zones, right? Looks to me like there's a little bit of a cold front right there. How do I know that's a cold front?
And blue?
Because it's coming behind.
Okay, the blue maybe is an indicator. It's slightly blue. This is a cold front coming in. What? Even if it wasn't colored, I can still tell this was a cold front. Anybody know why?
Because it's coming behind the cloud.
Okay, but this one's coming behind the cloud, so how come this one is not a cold front? Nate? How do I know this one, even without the color, how would I know this one is a cold front
The cold
and
front
this one's a
goes-
warm front?
The cold goes under.
Very good. This one's pushing in underneath the other one. This one right here, as it's pushing in, it pushes up on top, right? So I'm looking at this one going, I know this is a cold front because it's pushing in under the warm air. Because we know there is a density difference. Cold air is much denser than warm air.
You can also tell because the way the arrow is pointing, like the arrow itself is pointing towards it.
Okay, so the arrow's saying it's pushing in, and then this arrow is also showing that it's pushing up.
And then
So that
the
arrow's
other
gonna
one
help
over
to
there,
tell us.
The back of the arrow is like pointing that way.
Very good. Okay? So back to that question, why do clouds form, and why are they abundant near frontal zones? Why do they form near frontal zones? Why are clouds abundant in those zones? Yes, ma'am.
Could it be because, like, when the clouds, when they form, they condense, so, like, when that cold air is pushing into that warm air from the fronts?
Good. Yes, that cold air, it's pushing in, causing condensation to occur where the cold air comes in contact with the warm air. It's a lot like our fish tank in the back room. Here in another couple weeks, because we got the chiller running, if we have some warm days, we're going to notice a lot of condensation occurring on the outside of that tank. That water inside the tank is very cold. The air outside the tank ends up being warm. Where the warm air comes in contact with cold air, there's going to be condensation that occurs. And in that case, it forms right on the glass of the tank. Yes, ma'am?
What's the bottom?
We're going to get there.
Oh, wait, and I have another one.
So, that the top left one, is that one a cold front? How does the right one show a warm front? Because wouldn't it be the cold front go in the area, or like the bottom? Or before the other one?
For a warm front? Warm fronts don't typically push in. I mean, they can, but typically when a warm front occurs, it's when where a warm front occurs and pushes in, it really just rides right up on top. Is that what you're asking?
Yeah, so is there ever really Oh.
So this air mass is kind of moving this way. It might be moving this way a little bit, but if it was moving this way, it would be a cold front. Because it'd be pushing in this way.
Okay. So then how does it, like, how does it
How does it become a warm front? Just simply this air is warmer than the other air. So as it moves across, that leading edge, that frontal area, as the warm air pushes in, it is a warm front. So anytime we're talking about a warm front, it's when warm air is pushing into a new location. If it's a cold front, cold air is pushing into a new location. Sure. Absolutely. It will usually over a 12-hour period, maybe even shorter, it gradually warms up.
So then, would the cold front like go away?
Cold front would continue to get pushed this way.
Oh,
Because
so
of being in the westerlies, it would continue to get pushed to the east.
So then the warm front
And the warm front would come in and replace it.
okay.
And it would hang out there until probably another cold front comes in behind it.
Okay.
Okay? Alright, so looking at these two pictures, Ms. Wolf brought up a great point. She said, well, what's going on down here? This down here is a combination of these two. Okay, so we've got this cold air mass that gets pushed out. And this cold air mass might be moving kind of slow. This cold air mass over here might be moving really fast. So what happens is, this cold air mass continues to push in, it pushes through the warm air mass and comes in contact with the cold air mass out front. What happened to all of that warm air? It got pushed up. All that warm air got pushed up right here. Anytime we have warm air getting pushed up due to there being three air masses coming in contact with one another, we get what's called an occluded front. It is a situation where warm air is pushed up on top of two cold air masses. At the boundaries, right here, we have condensation occurring. Usually higher up in the atmosphere that condensation occurs. And a lot of times at ground level, we never notice that there's warm air. It's pretty cold, pretty damp, pretty rainy. And we really just notice this cold air mass kind of comes in and pushes past. And this cold air mass might be a little bit warmer, a little bit colder than this one, but our weather really doesn't change a whole drastic amount. This other air mass comes in, pushes through, and we never actually received that warm air at ground level. It all occurred up high, causing condensation, which led to precipitation. Yes, sir?
I always had this question, how do clouds move? Is that because of the global wind?
Because of the global winds, yes. And local winds can play into that. If we have counterclockwise rotation to a mid-latitude cyclone, we might get winds that are coming out of the east for a short amount of time, but that entire system, as it moves over the United States, is pushing from west to the east. So, because it's got counterclockwise rotation, our wind might come out of the east. That doesn't mean that the system isn't moving to the east.
That's how clouds are moving?
That's how clouds are moving. Those winds are directing the clouds in their movement. Yes, sir? Okay, last question, real quick. Which type of front would you expect to have the narrowest zone of precipitation and why? This, I want you guys, we'll talk about it together, but I want you guys to think about it for a second, and then we'll have a discussion over it together.